do another one. Another question that they have on the test is they have like kilowatt hour problems. Okay, so I'm going to type this question out and then we can work it out. I just don't want to write it with the thing. Okay, so this says if the local power company charges how much will it cost to use a 2.3 kilowatt oven for 45 minutes? Okay. Oh, I did not type mins right. Oh dear. Well, this is supposed to be minutes. Okay. So let's see what we've got here. When you do these problems, I like to keep the units in these so I can see what I'm doing. But basically, if your oven is not in kilowatts already, which they have it already in kilowatts. Let's pretend that it wasn't, just so we can get some practice. Okay, let's pretend that they said 2300 watts. Okay, so they have the first thing you want to do with these problems is you want to convert those watts to kilowatts. And I know they already had it that way, but some of the problems don't, and I want to make sure you guys know how to do it. Okay, so we've got our watts, right? 1,000 watts in 1 kilowatt, and we're going to get 2.3 kilowatts. Okay, that's the big thing that a lot of people do. They forget to do convert it to kilowatts. Luckily, this one already had it, but we pretended it didn't, just so we know. Okay, then I'm going to take my 2.3 kilowatts and I'm going to multiply it by 45 minutes, except my minutes, I need to convert those minutes to hours. Now, if I was really smart, I would have done that ahead of time, but it's okay. I would have converted that in step 1 when I did the other one, but I wasn't really paying attention. Okay, so we have 60 minutes and 1 hour. Um, 1 hour. Okay, and we're going to get 0.75, which I kind of already knew that. Which is why I didn't think about converting it. So I'm going to have 2.3 kilowatts times 0.75 hour. Okay, this is supposed to be a 7. Okay, and I'm going to get an answer. Okay, let me get my calculator, see what it says. 2.3 times 0.75. I'm going to get 1.725 kilowatt hours. Okay, then I can take my 1.725 kilowatt hours and see how much money that's going to cost. And just a hint, if you get a huge number, you did it wrong. Okay, because if it costs you like $30 to turn on your oven for 45 minutes, nobody's going to cook at home, right? They're going to go buy stuff somewhere else, right? That's way too expensive. Nobody can afford an oven that costs that much. So, just see if your answer makes sense, right? If it says that your light bulb cost, $10 for an hour, okay, I know electricity is expensive, but it's not that much, right? You couldn't afford that. Okay, so just, use some common sense. My kilowatt hours are going to cross out, right? So I had 5 cents per kilowatt hour. So I'm going to do 1.725, and I'm going to multiply that by 0.05, which is like half of a cent actually. And so it says that it costs us 0.086. Okay, so um, right, that's like, what is that, 8 cents, 8.6 cents, so 9 cents. That's how much it would cost to run your oven. That makes sense, right? I can handle paying 9 cents to run my oven to cook some potatoes. I cannot handle $20 to run my oven to cook some potatoes. So, you know, use your common sense. So those are problems. And there is a problem like this that's a short answer problem on your test. And it's really important that you show all your work. I know it's annoying to type your work into those little text boxes. I know it's not the best format, but you really have to show your work. If you show your work and I can see that, you made like a little error somewhere, I can give you partial credit. And plus, a problem like this would be worth 2 points. Okay? Which means 1 point is for your work and 1 point is for the answer. So even if you get the perfect answer, you just got half of it off by just not showing your work. So I know it's annoying to type your work into those text boxes, but please do, because I can give you partial credit, and then you're going to get full credit on the problem, which you're not going to get full credit if you don't do that. Okay. Now let me see. Let's do some Ohm's law stuff. Okay, so I'm going to stop this one, and I'm going to let's do a new problem. Okay. So let's say that we have a voltage of 9 volts. Okay, and then we have a resistance of 30. Okay, I'm just making stuff up. Okay, and they're asking you for the current. Okay, that means you're going to use this formula. Okay, so we have R equals V over I. I'm going to put it in the triangle. And I is what I want. So I equals V over R. Okay, so that means I'm going to do 9 divided by 30. I'm going to get a tiny number, and that's okay because current usually is pretty small. Okay, 0.3. Okay, let's try a different one. Let's say that we have a current of 0.3 and a voltage of 9, and we're going to look for our resistance, right? So I'm using the same numbers from the problem above, right? So that should tell you that our resistance should be 30. So if we get 30, we know we did the right. We know we did it right. So we do R equals V over I. Since we're looking for R, we don't have to put anything in the triangle. We're just going to do 9 divided by 0.3. And here we go, 30. Okay, now here's a something to just kind of help you. I know some people put stuff in the calculator upside down. They'll do like 0.3 divided by 9, and they'll get the wrong answer. your current is small and your current is on the bottom, which means when you put this in the calculator, you should get an answer that is bigger than what you've already got right here, okay, than this, okay? So if I did 0.3 divided by 9, I would get a small number, but since I'm doing 9 divided by 0.3, I'm getting a bigger number, okay? And we got 30, which is what we wanted. That makes sense. Okay, let's try this one more time. Let's say that we have a current of 0.3, and that we have a resistance of 30, and we want to know our voltage, right? So we know that our voltage should be 9, right? Because that's what it is in the previous problem, right? And I'm using the exact same numbers. I'm doing that on purpose because I want you guys to see that we're getting the right answer. So we do R equals V over I. Okay, I'm going to need to put this in the triangle because I don't want to do any algebra. So I'm going to have R, V, and I, and I'm looking for V. So V equals IR. Okay, so then we can do 0.3 times 30 equals, I know what it's supposed to be, right? It's supposed to be 9, but I'm going to go ahead and put it in my calculator just to be okay. So then we've got 9 volts. Now, if this is a short answer question on your test, you have to show your work, okay? You have to do V equals IR, 0.3 times 30 equals 9 volts. If you do not do that, you will not get full credit. You'll get 1 point for having the right answer, and you get 1 point for showing your work. A cool thing is if you get the wrong answer, but you showed your work, you still get that point, okay? So in order to get both, you've got to show your work, and get the answer. Okay, and that's the way to get full credit on those quizzes, out of those tests. Now let's try something else. Okay, now there is a power formula. Okay, it is P equals V squared over R. Okay, so let's do a problem. Okay, let's see. Let's say we have a 110 volt source is connected to a 20 ohm resistor. How much power will it use? Okay, so in this one, we have a voltage of 110. Gosh, I cannot get it to write V's for the life of me. Okay, 110 volts. And then our resistance is 20 ohms. Okay, and what is my power? Right, and remember power is in watts. Okay, so to solve this problem, we have to do P equals V squared over R. Okay, now when I type this in the calculator, I'm going to have to type it in like this. If I do not, I will not get the right answer. Okay, and I probably, when I would type it in, I would probably do that too, just to be safe, because I'm really particular. I don't want to do all this work and then not get it right. Okay, so I'm going to have 110 squared. If I'm going to type it like that, I've got to do another parenthesis. So we want the calculator to know that we want to do this top stuff first before this bottom stuff. Okay. So now let me put this in the calculator. And I'm going to get 605. And the units for that is watts. Okay. You could also type 0.605 kilowatts if you wanted, I guess. So that's how you would solve a problem like that. What's really important is these parentheses. Again, if this is a short answer, you've got to show your work. You'll only get half credit for this. All of this is worth the other point. Okay, you've got to do both. Okay, let's try something else.